Hello and welcome to the SCI-AI podcast. This is episode number 20. Today, with so much pleasure and excitement, I would like to introduce to you all Daniel Jue. Daniel is an artificial general intelligence researcher. In 2015, he formed Cognami as a commercial entity with which to pursue the effort of AGI. He is a computer scientist and he is following the approach of incorporating philosophy and psychology in building a great AGI at Cognami. And this will be the theme of our podcast as well today, adding philosophical terms and trying to understand general intelligence from a very, very holistic perspective. So welcome to the podcast, Daniel. Do you want to share something before we get started?
Yeah, thanks, Vivek. It's great to be back on again and talking with you about AGI and the areas around it. So, yeah, I think we can get started and have a nice dialogue about AGI today.
Excellent. I'm so excited to have you again, Daniel. What is human consciousness and how will you write an algorithm to write emotions and be alert and alive? Like smell, taste, etc.
Sure.
And not just display the characteristics of it to the outer world like you're faking it, but how would you put those emotions like it actually feels by building the right kind of cognitive architectures? So, yeah.
Yeah, and I mean, we really don't know much about consciousness. Like there's people that have written book like Daniel Dennett on consciousness and explaining away consciousness. And there's still so much that we don't understand and that our language is lacking in explaining, some of these basic concepts of conscious sensory experience and the way that we feel certain senses that our bodies are allowed to feel. And, beyond the 5 or 6 senses that we talk about with, that we have names for, there's all these other technical senses that you never really think of, like, the sensation of hunger and the sensation of, hot and cold and the pressure on your fingers and things like that. There's other types of sensory channels you could think of. And when you think about that more deeply as far as the range of senses that we have that contribute to our conscious sensory experience of the world, you end up having to abstract things a bit more in the way a computer scientist would or some sort of abstract theorist would. And you end up having sort of these abstract sensory channels where we don't have very much conscious introspection as to how those senses are contributing to our understanding or what thoughts are going on in our heads. So, and these are things that when you, maybe if your audience have done anything like meditation where you're trying to become conscious of these different sensations of the feeling of your weight in the chair and kind of clearing your mind of high level conscious thought in order to kind of be more in touch with your base feelings of sensations from your toes to your head and things like that, then you start to understand that we need to make the system that we would build would have to have the ability to have an abstract and unknown number of sensory channels that all contribute to the system's understanding, but in a similar way to us the system might not be able to introspect on why it feels a certain way or what gave it intuition as to its, why it came up with a certain idea or solution or conclusion. So I think that's one way that in order to write an algorithm, it's not really writing an algorithm as so much as it is designing a foundation for which new senses could be incorporated and added to a system that would be different than ours. There's nothing, and still have that contribute to its type of consciousness, which would be different than ours. So you can imagine a human that is lacking some senses for some pathological reason or some kind of disability, and that person is still human. We still think of the person as human, and we expect that it has a similar conscious experience. But a colorblind person has a different sensation of seeing the color red than we would, that people that are able-bodied. So that it doesn't really detract from the wholeness of their humanity, but they do experience a different type of conscious sensory experience when they don't have certain sensory channels. So in a similar way, computers would be even more different because they would have different types of senses that would be, not the same as our biological senses that have enabled us to survive, but it might have a sense of how much power it's using, or how much, how low its battery is, or how, other types of senses, I would say. Let's just leave it at that.
Right.
So
no, that's a great point. Yeah. They might be conscious, but their consciousness means a little different than ours, because you're right. I mean, as we have evolved to become such a species because of hundreds and thousands of years of evolution. So, I mean, even though we have achieved a lot of intelligence in terms of how to create these kind of great AGI machines or AI machines, we will still not be able to do the work that nature has done for us in these thousands of years by adding contextually why we feel those emotions we feel, sometimes subconsciously, because we do not understand why we react in a certain way.
That's something that's you go back to why we have these senses at all, and they've contributed to our survival mechanisms, and that's how they've evolved, and we've kept having these senses, and these senses have gained in their acuity and the definition of our eyes, and we have made use of these senses in combination. So for instance, when I'm looking at your face and going at having these social interactions, now we're combining different sensory inputs to project about theories of mind, and what is the other person thinking, and helping us to navigate social interactions. So it's not just the base senses, but then you have combinations of these senses, and looking at the whites of other people's eyes, and how that allows you to judge people's feelings and respond appropriately and navigate social situations. So a computer system that we would call an AGI would have necessarily different types of senses. It would need to have some of the similar senses in order to be able to interact with us, but it would have other sensory input channels that are very different and might only make sense to other AGIs. So you could think of a society of minds, of AGI minds, being able to develop their own culture and have the ability to develop language and communication skills between them to navigate their own, social networks. So this is something we should allow for. And when we talk about AGI, a lot of times our language fails us, and when we say things like human-like AGI, like we try to simplify it into a simple term. But we should think of human-like AGI as something where we're inspired by humans, but not necessarily so much like humans. So not really not anthropomorphizing the AGI so that it would essentially be exactly like a human, but that it would be able to incorporate different sensory channels the way a human does, which is like a lower level of
right.
How like is it? Is it? Are we trying to make a copy with a silicone skin like Ben Goertzel's Sophia, or are we trying to make something that has the ability to do advanced pattern matching and abstract thought on
Let me give a little brief about the game Go.
Unknown number of sensory channels that are very different than ours.
Great. So for our listeners, the game called Go is a board game developed in China about 2000 years ago, and till today it's a very, very loved and famous game that everybody wants to play and love to play. So recently, I think about a decade ago, Google's DeepMind developed AlphaGo, which had actually beaten Lee Sedol, the world champion in the board game Go, in 2016. So what do you think? How did Google's DeepMind sort of created that kind of intelligence, using deep reinforcement learning or other methods in order to create such a strong, better than human level intelligence?
My understanding of, of AlphaGo is that they essentially Well, for a little bit more background about the game of Go, I think the number of possible board combinations, if you try to enumerate all of them, would be more than the number of particles in the universe. So it's like you can't do a traditional type of search space where you're, even the game of chess had so many combinations that the search space was intractable by normal means. So you had heuristics that you were programming into it to find the best move and predict, n number of moves out, where n is something small like 5 or 8 moves out. And you have this branching tree structure of possible moves. So with Go, that's even more intractable, because the number of, I forget what the numbers are, but the tree grows at even more exponential rate. So one of the techniques that they use for the reinforcement learning, as far as I remember, is that they had the program play itself with just the basic rules of Go, but not any strategies built in. So you're not trying to bake in, known heuristics from humans, and that you had it play itself, and then it knew the rules of the game to see who would win, and then it would play these games to completion, and eventually start to look for patterns within the computer systems that won against, the computer system B, or player 1 versus player B. And then it could play, millions and millions or billions of games against itself, and then develop patterns of what works and what doesn't. And that's what came, I think it was it move 33 or something like this in the game, where it amazed all these veteran Go players because they had never seen this strategy before. And then that was the moment that I think it was Lisa Dahl was saying that, it's like this computer is like, way outmatching me, and there's no way I can beat it, because it came up with this move that was just like unseen and unheard of, because it had developed different theories of how to play the game outside of human experience of playing the game. So that's, something that's pretty amazing, and it was inspiring to see that happen, and it's conquered the game of Go essentially. So there's no human player that right now can beat it, and it probably would not beat it. So, and you could imagine that if you were able to play a billion games of Go, you would come up with probably different strategies than, and also play a billion games of Go without any human teachers. So obviously your learning is going to deviate from the human path of learning the game of Go even after 2,000 years.
So isn't it fascinating that something that does not have a knowledge of rules, somebody who does not understand how it needs to be played, but just by trial and error, by playing a lot of games by itself, the algorithm learned the ways to not just beat Lisa Dahl, but sort of, like you said, the number 33 move that it played was mind-blowing, because what I understood from chess and Go is that there can be so many possible scenarios that you can play with. The most amazing players, the best of the world, play it with a lot of intuition. So because our brains have a limitation of not being able to understand or clearly remember all the moves at the same time, because we have a small processor or RAM size in our brains probably. So the fascinating stuff is that this computer actually understands that, and not just understands it, but amazes us by showing something. Yeah. Amazing.
And I wouldn't say that it might be a reach to say that it understands it, that it's, maybe any more than we say we understand the game of Go. But and there's been, just to having a little aside there, there's been a great deal of discussion between some of the AGI people in the field of AGI that I communicate with, where we've had discussions and talks and opinions about what it means to understand something. So drawing a lot on philosophical talks and delving into that arena. A lot of us are not philosophers by default. We're people that are involved in computer programming and software engineering that are pursuing AGI and then dipping our toes into what philosophers have come up with over the last few hundred years and even further back. So to understand the game of Go is, I'm not sure I would phrase it that way, but it's definitely come up with rules of its own or heuristics of its own, I would say, by knowing the basic rules of the game. So that's, and if you think about it, it's what we should expect with a game that could vary so much. The way we've navigated that search space of how to play a game of Go based on our intuition is only one of many paths to succeeding at the game of Go. So having something that's kind of trained on its own and played against itself has come up with different theories. And, this is one of the joys of being an independent AGI researcher, is that you are kind of in a way coming up with ideas on your own and pursuing opinions of your own and following to their end as far as you can take them, but not being essentially trained every step of the way by what other people have said, their heuristics of how to do something.
And yeah, you're right. You're not still bogged down by the pressure of board and investments and, something that can convolute your ideas that you have for AGI.
That's another topic we can get into as far as the marketability of AGI and the monies that would need to be put into the type of research that needs to happen.
So in order to build the strong AI or an AGI, we need to be able to build deep neural networks. How will then these huge neural networks make use of big data? Because without building great models using big data and cognitive architectures, how do you think will we ever be able to build the right kind of AGI? What kind of work are you doing in this?
It's a bit of there's some assumptions in that statement in question. So
yes,
I would say that none of us really have an exact recipe for building an AGI fully. Like a lot of people have come out and said, oh, I have the recipe for this or that, but it's still open for exploration. And I would encourage anybody interested in it to get into it and think about what it would take to build an AGI and not just assume that it's been solved. It's a very open field, and there's not enough players in it. There's a few of us that are actually kind of devoting our lives to pursuing it fully, and sacrificing a lot to do it. So I wouldn't assume that having a deep neural networks, especially the ones that are popularized today, is a necessity for AGI. I would say it might be sufficient, but it's not necessary. So this is I think there will probably be multiple paths towards an AGI, and that making use of deep neural networks, or just say neural networks, is probably going to help. But I don't think especially today's neural network architectures, I don't think that they are required or the only way. And I think that the neurons that we have in our brain are so much more complex than we understand even. And then they're kind of like, there's some unknowns about how the human brain works and how the neural networks in our brain actually work. And then we have some sort of understanding. We have a model of it that's kind of approximate to what we think how it works, right? And we're the neuroscientists. They're out there making advancements in that. And then the neural networks that we use in our computer systems right now, the ones that are so popular that 99% of the world is using, it's way down here as far as how simple they are, and especially not just how the combinations of them work, but actually the neurons themselves and what constitutes a neuron in those systems it's very, very simple and rudimentary. So I think that the idea, the concept of a neural net helps, but it's not like the ones that are popularized today, that we'll end up using something that looks like a bit like a neural net because it's so generalizable and so useful, but it's not going to be something that needs to run on a GPU, and it's not importing PyTorch or TensorFlow. So that's my opinion on that. Now, as far as the other part of the question, making use of big data, I think the goal should not be to build models, but to build something that builds the models, that is conscious of building its own models. So, where I'm aiming at it with my research is something much more rudimentary, where it's being able to introspect on its own thoughts and having where the base level unit is something like a unit of a concept or some sort of conscious sensory experience, where this is something that the system is able to introspect on and have thoughts about its own thoughts. So that's kind of the level I'm approaching it at, where it could make use of neural networks kind of to process sensory experience that is coming in through a sensory channel, but not necessarily, just processing. It's not like today's uses of neural nets in that regard. So there's there's a necessity for a higher level ability for cognition, and the substrate underneath needs to be able to allow those types of higher levels of cognition to manifest or emerge out of. So you could think of the system that we're working on is defining the base physics of the system. You might even call it metaphysics, but it's the base ideas of having a thought and having concepts and forming concepts, but not anything about what the concepts are or about how, the ability to have pattern recognition, but it's not saying what the pattern recognizers recognize. So to be able to make use of a new type of input that we develop and not have to scrap everything that was related to, say, processing an image or sound or video or a web page or text. And we also work at a much lower level of what the system should be able to understand. So a lot of people that are going into wanting to research AGI, they start with chatbots and they think, oh, well, let's make it, pretend to be a human and have these high level conscious structures that require social input and cultural norms and, the nuances of language even. But we start at a much, much lower level so that language is something that could be developed on top of this, and that culture is something that could be developed on top of it. And, it's kind of laying, designing the primordial ooze for which life could evolve out of is the approach that we're taking. So I think that's where it's different than a lot of other AGI approaches, and definitely a lot different than the narrow or weak AI that's so popular today.
Yeah. So since you've gone into, language and consciousness, can I ask you a connected question to it, which is, do you think that language is one of the most important things while building consciousness? I have done some other podcasts as well and read a lot about this, that the reason why we are self-aware, the reason why we could form communities and we could be so intelligent compared to other mammals is because of the reason that we have developed language. So do you think that helps building very intelligent sort of species? Not saying maybe necessarily AGI, because I don't know how much important that aspect is, the aspect of language. But
language is definitely crucial to having society and culture. You don't have cultural transmission really without language. I'm not a language expert, but from what I've gathered and from what I see, my intuition is that instead of approaching today's human as what we should emulate, we should be maybe emulating, I guess, what I'll refer to as like a proto-human. So a human just before the advent of language, so that language is something that it could evolve on its own when it feels the need to communicate with other AGIs that are its peers. And that language would be obviously different than ours, but let's go, instead of trying to make a 2022 human, let's go with all the nuances of our culture and all this baggage of thousands of years of language and norms and things like that, and styles of communication. Let's go back to just before language was created, or even further back, maybe to in prehistoric times. I think there was some sort of carving, alabaster carving, or some sort of carving of like what was it? It was like a a lion with some sort of torso of a human or something like that. You know, it was like the ability to create the concept of something that doesn't exist. And some people point to that as the root of philosophy and the root of being able to philosophize and think about things that are not in existence, to have abstract thoughts. So you can think of when you create something that doesn't exist, you've created an abstract thought. And the system needs to be able to have these things and then to develop its own language. So instead of trying to preload it with all of our language and all of our baggage and expecting it to essentially pull a trick over us with Turing tests and things of that nature, and fooling us into believing it has emotions or humans or has the same sensory experience that we would have. Instead of trickery, try to make something that's genuine, that evolves on its own and has developed higher levels of cognition on its own. So that's kind of where we're heading.
So how human is GPT-3? How close do you think it is to passing a Turing test? Can you share the knowledge in terms of, like, an example, like how would a human will react to questions compared to?
Yeah, so I mean, GPT-3, it's a great experiment. The GPT, the different series and 4 and 5 and what they postulate the next generations might be able to do. Yeah. Obviously, it's going to get better and better at fooling us that it is human, but it's still just fooling us. It doesn't have its own motivations or interests, or it's not something that's running somewhere introspecting on its own thoughts. It's not something that's alive in the sense that we are alive. Or that we think that we're alive by having thoughts. And so I think it's just going to, it will probably continue because it is useful. It's able to, basically be trained on large corpus of information and data, and then make some new useful combinations of these things. I can say, oh, let's imagine write me a TV script for about a duck that rides a bicycle. And it'll come up with a theme about something that's never been, a human has never written, but is plausible and it's useful for our means to sell, or, it's useful to be used in the marketplace. And I think, AlphaFold is another one that's useful. It's a great way to, generate new ideas on how proteins fold and can be used to generate things that are useful for humanity. So in both respects, they're useful, but it is not AGI, and I don't think it will lead to AGI. I think there are probably some useful technologies at its core with transformers and transfer learning, things like that, where the concepts, the base concepts are something that is useful, but the way it's implemented it's not really a path towards AGI. It's a path towards more trickery, but trickery has sort of a pejorative connotation, but it doesn't mean that it's not useful. So it will be useful for humanity, especially for things that we want to sell and use it for creative purposes to generate new images with DALL-E, or create new types of music, or create new poetry, things like this. It's for entertainment uses or for selling creative content. It's going to be, hugely useful.
Right. Great answer. So it can become a great tool.
It's more of an immediate tool to use, right? And it's something that, people are interested in. They should pursue it. And I'm sure there will be more great discoveries with further iterations of GPT, as well as the spin-offs that are doing other things with language and other things with images and image generation and content creation in general.
Great answer. So will hybrid AI be able to build a really strong AI or an AGI? Hybrid AI means the combination of neural networks and classic rule-based AI, because they can together help overcome the problem of deep learning and its limitations. So so what do you think?
Yeah, so I think that when you want to start building, using deep neural networks and using rule-based AI as or rule-based programming as a building block or as a component, you start building with bigger components, and then you can get a more generalizable system that way.
Right.
So I think that the system that will result in an AGI, I think you would necessarily have to call it hybrid, but maybe not in that sense. It would have to rely on something more than just neural nets, more than just rule-based. It will be a combination of different types of ideas. I think it will take, I think that both rule-based AI in the way that, you think of expert systems, and then neural networks today, the way we think of deep neural networks, I think those are still both things that are acting at too high level, or maybe not abstract enough. And that there's some sort of lower level framework that allows models of reality to be constructed on its own. Models of understanding is what I mean by models of realities. There's probably some, base reality that exists, and the best we can do to navigate this world is to come up with models based on our observations and being in the world and being able to act on the world that makes sense in some domain. And that, we have to be able to hold in our brains, the way that we do, we would have to be able to hold, the AGI would have to be able to hold multiple models that are sometimes conflicting with each other, but are, at different times useful. So you think of an AGI that came up with Newtonian physics and an AGI that came up with relativistic physics, based on observations, but both are very useful, like in their own domains. So, it's a lot less complex to run Newtonian physics equations, when you're traveling like way less than the speed of light, for instance. And so, to be able to have conflicting models, I think is something that humans do really well. And we like to say that we don't have cognitive dissonance and conflicting models, but it's something that humans do very well with. We don't crash when we have models that conflict with each other.
Yes. So we will move to the next one. How much of the brain do we understand today? If we don't understand our brains completely yet, do you think that we can build sentient AI that can really transform our species? Because without building or without understanding how the neurons in our brain connect, when do they trigger an emotion, when do they, provide something that is really, really creative or intelligence, then how would we put that into an algorithm?
I see.
Is where I'm trying to get into. So, yeah. Don't you think that, it's a monumental problem to first understand and then
and I think
build something around it?
I think if we waited to understand everything, that we would just never develop AGI. I think that's the case. And I think that we have to try experimentally developing things until we find cases where it doesn't apply, or we go with what we know until we've pushed the boundary into, hey, this doesn't act the way that we think our brains work. And then you have to go back and reassess and change, assess where we went wrong and change that. So I don't think that, as far as how much we understand, I have no idea, but I would guess that we know very little about the base reality of how our brains work, and that, compared to where we are with full understanding being on one side and zero understanding being on the other side, we're probably just a little bit over. Like we've done a lot of work for sure. A lot of human hours have been put into trying to understand and coming up with theories and testing those theories and adjusting those theories when it was wrong, or when we think it was wrong. And there's been revolutions of science and engineering and understanding. And I think we're probably not going to ever get to a place where we fully understand how everything works in our brains. And but I don't think that we should try to wait until we understand halfway, or we'll never even know. Like when we reached, now we understand the brain 50%, right? So we don't even know the extent of how much we don't know. We know that our brains are very complex, and they're amazing. They're amazing, computational machines. But and maybe it would make, you would have to understand more of it if you were trying to create a new biological brain from arranging molecules or something like that. Then in that case, yes, you would know, you would need to know pretty much exactly how the brain works and how all these mechanisms work together. But that's not what we're trying to do with AGI. We're not trying to build a biological brain. We're not trying to emulate a human exactly.
Right.
We needed to have some sort of
Right.
human-like capabilities in order for us to interact with it and for it to exist alongside us. Right. We need to be able to communicate with it and reason with it and have it make sense and make use of the world and give us answers and maybe do things for us, work together with us. So we needed to have some human aspects of humanity, but not everything. And
Right. No, that's a great point. Yeah. Yes. And adding on to that, I was also thinking that, why does an AGI even need to sort of copy the human brain in order to be really, really intelligent? Because if DeepMind can do something without actually mimicking the brain, then the AGI can definitely be built without sort of mimicking or copying exactly how the neural networks in our brains work. So creating a parallel sort of intelligence rather than creating something that we already know, right?
Yeah, I think that's
so.
So
yeah, I mean, yeah,
it would definitely be something that, because it has different conscious sensory experience than us, an AGI, or at least the AGI that we're attempting here at Cognami, it's going to have a different set of experience than we would be able to experience. And there would be some crossover where it's able to communicate with us in a meaningful way to us. So it will need to have some ability to learn language and express what its consciousness is doing and what its thoughts are, or either that, or we would have to try and introspect it, which is probably going to be as bad as us trying to introspect on what a deep neural network is doing, which right now we have big problems with explainability in those systems. All right. But maybe we could go back to the idea that maybe you can start that one over again. Could you start that one over again? Yeah.
Yes. So what I was trying to share with you is that, like, DeepMind didn't actually need to, mimic our brains while still had created something which had beaten the best of humanity in a Go game. So similarly, I was of the opinion that we might not need to build an AGI which could have similar characteristics like us or sort of copying our brains, but a parallel intelligence, right? So something that could be exponentially intelligent than us, but may not have the same kind of intelligence that we have.
Yeah, I think that an AGI will have a different level of intelligence than us in different ways. As you mentioned before, it will be able to think more deeply on ideas and follow thoughts to further logical conclusions than we would have the concentration to do. It will also be able to scale outwards and think about multiple things simultaneously in parallel across different machines, across different hardware. So there's a lot of hardware challenges. There's inspiration we can take from big data about how to distribute work and then have that recombine later. And but there's also the aspect of, and this is more along the lines of where you see DeepMind and AlphaGo, where they're excelling at, is the ability to have this level of concentration and to think more deeply and not have these distractions and limitations that our meat brains have with, getting kind of running out of willpower to concentrate on a problem. This thing could, if it determines that a certain problem is of dire need to be thought about, it could think about it for, months on end without any interruptions. And, we just don't have the ability to do that. So we get distracted by life and our physical body needs and things that we have to attend to. But that's something that an AGI would not have to attend to. So the level of its both the width and the breadth of its intelligence would be far beyond ours, is what I was getting at.
Yes. So let's stick to the point of brain then. Our brain is so complex, that it is so hard to decode even after decades of research in the field of cognition and neuroplasticity or neuroscience and brain in itself. So let me ask you this then. Why is it so difficult? For example, we cannot reach to the far-flung galaxies of our universe because of limitations of the fact that, we just cannot reach there. It's so far, far away, and it's practically today not possible to reach there. So yes, we can understand that, doing research on them or trying to understand those galaxies or planets or star systems would be really difficult. But brain is something that is here with us, with this intelligent human for the last at least 100 years. I'm talking about since the time of Einstein or others. So why is it so difficult to understand it? Is it because of the fact that, there are so many possibilities in the brain that we cannot understand, and simply because of the fact that it is right under the skull where, it's hard to decode what's going on, when does it trigger something, through neurons,
you have to remember that the age of our science is just beginning. We've only been doing this for a few hundred years, and where things are advancing at a great pace, but the systems that we're trying to analyze are the most complex things that we know to exist as our human brain, and furthermore, our bodies are amazingly complex. These living things, unlike stars that we can observe, and science that we've developed to observe things that are distant through sort of proxy investigations and other types of data that we can collect. So, there's a lot of things that hinder us being able to introspect, things in our brain. We really don't do like destructive testing of our brain to see, besides some really gruesome type of surgeries that we've had in, hundreds of years ago, where they would drill into the brain and damage a part of it and then see what happened to the person afterwards. Right. So, or people that had these really bad brain injuries, and then they would observe, these things that happened, but they're very complex systems. So to know at a minute level what individual neurons do, or things like this, or individual structures of neurons, it's going to take some time. Give it more time. It's only been, we've only really been advancing on it for, maybe the last, 50, 60 years or so, and the tools are getting better. It is going to take some time. It's not just that it's not for lack of trying, although there are things that hinder us. We might have to do only these intrusive experiments on animals that have brains that are kind of like ours, but we have there's ethics that we need to adhere to whenever we work with humans, and putting things into human brains to kind of introspect what's going on. And we even have that with social sciences and with psychology. There's certain experiments, but we've deemed that are too cruel to do, so that we kind of necessarily hamstring ourselves, which means holding ourselves back from doing just any type of experiments, to what we can kind of ethically and morally deal with as far as what we should do to another human, because we believe in this kind of sacredness of life. So there's, especially of human life, above others, right? We could do experiments on little mice and cats and things like that, where we wire head them, but there's only so much we can do to a human while they're still living. So I think it's just going to take more time. Yeah, I'm not a neuroscientist, but I know that those people that are neuroscientists are working very hard. They're making great discoveries at the fastest pace that they probably can. With again, I think it's something that we don't need to fully understand to get to AGI. I think that AGI will come before full understanding of the human brain, even though it's sitting here, right between our ears. It's something that we will probably not understand on our own. We would need something like AGI to help us understand if that's something that we care about, maybe just for curiosity's sake, right? What each of our neurons is doing. But,
yeah, I was actually coming to that point that we will build such strong artificial machines in the future that perhaps they will have the cognition of understanding our brains better than we ourselves. So that'll be a fascinating time in the future, that the rewards or the artificial intelligent machines will tell us, hey, you know what? I have discovered something about your brain.
Yeah, that's my rationale for the excitement that I have for AGI, is that my brain and my meat brain does not have the level of concentration to be able to work out the complexities of the human brain or other aspects of our existence. But I could build something that has, for all practical purposes, an infinite level of concentration that could go off and discover things on its own without the limitations we have as these biological beings. So I think that AGI will be the ultimate tool to discover things that humans would just not be able to discover on their own.
Fantastic. Great point. And in the previous podcast with Dr. Michael Wu, another AI researcher, he was of the point about diversity, in technology, and especially in AI, and the ideas from different parts of the world, and also diverse ideas in the field will actually eventually make it really great. So my point was that, how diversity is also so much important in creating a very strong AGI, because let's say if a particular set of scientists or researchers in the field of AGI starts thinking just in a particular sort of direction, or in a direction which will benefit them in a certain way in their own biases, then perhaps that is something that our future generations wouldn't want it. They would have wanted from us to do a very, very holistic sort of research in the field of AGI, right? Which is adding more diverse ideas from all kinds of people and researchers. And so somebody might bring in an idea of adding philosophy, like you said, right, to AGI, psychology, and somebody might just say, let's create one of the best programs or algorithms to power AGI in a certain way. So
I think that's, diversity of ideas is very important. And the perspectives, obviously there's a lot of loaded political things that come up with diversity, but it is very important to have, if you're going to be baking in ideas into a system, you need to have these multiple perspectives where those ideas originate. So if you were building a system that was going to incorporate all of your opinions and your ideas about how to model the world, then, it's going to be, one is going to be kind of a fragile system, and probably, and then it's going to be weaker than a system that is able to incorporate ideas from other people. Now, so one way that we are going around requiring a great deal of diversity is to not build in any of the assumptions or ideas or political or ideological beliefs into the system, but instead building an underlying framework that allows the system to incorporate and acquire these ideas and of other people, and read the literature of philosophers and take in ideas from its existence in the world, rather than force our rules and beliefs into the system, and build a system that itself values diversity, rather than just have a diverse committee of people that are all pouring their models of the world into the system, right? I think it's important from an ethics perspective to not bake in the ideas of even today's humanity. Like we might consider ourselves to be enlightened as far as how humanity should exist with each other, but that's what people 50 or 100 years ago would have also said about themselves. So instead, we should build a system that is adaptable and can acquire, I would say, like elevated views of we would normally say of humanity, but elevated views of intelligent life and how that intelligent life should work with each other, and types of systems of thinking and systems of government and systems of equations. It should be able to introspect about its own thoughts and think about its own thoughts to, in the same way that we can hopefully, especially your viewers would be able to, they think about your own thoughts. And if you see that you had this false conclusion, then you change your ideas. So you should have the ability to change your mind and come up, evolve as a human and come up with better ideas of how you should exist and how you should deal with the world. So that's something that what we're building here at Cognami is that framework that allows change of being. So it allows the system to adapt and learn about its own thinking and change the patterns of its own thoughts.
So what is causality? How important are creating causal models in making great predictions using AI in the field of healthcare to save lives and find better cure, much faster and more accurate? And perhaps, let's say, not just in healthcare, but agriculture, climate change solutions, understanding criminal behavior better, and so much more. So, so what do you think about it?
Being able to have the ability to generate causal models is what I think is important, instead of baking in our own causal models. It can learn of them, but it shouldn't be something that's maybe hard code. It shouldn't be something that's hard coded into the system. With the advent of big data in the last decade or so, there's people that have been using big data correlations as a shortcut, instead of, a shortcut to get something meaningful, instead of trying to look at the root, the causality of a complex system. So, causality is important because it, allows you to essentially predict something will follow some other event, right? So you're, predicting the future, with you assume linear time, and the time is advancing, and that is always advancing, so that, if you see something, something else follows. And that allows us to reason about the world in a better way, in a more accurate way, which enhances our survival when you apply it to the right topics. So if I say that, with smoking, I will likely get some kind of cancer, then you can avoid smoking, because in a lot of cases leads to it. It's not 100% correlation, but it's enough that you can use it to better your chances at having a longer lifespan, because that's, the fear of perishing is an innate fear for biological beings, right? So being able to avoid or prolong our life until that untimely end, that's something that we've been doing ever since we were alive, right? Ever since there were things living, there are things trying to prolong its lifespan, and using tools like a higher level cognition and looking for causality or looking for correlations, right? And, what we thought of as, we look down on the superstitions of old, but that's really, because of people trying to make sense of the world. So it's sense making, it's causality with a high enough percentage of accuracy that we call them causal models, even if we don't really understand exactly, what's going on. So, we would have no trouble teaching our next generation that smoking would give you cancer, even though it's not 100%. Not all smokers get cancer, but
right.
It's our way of making sense of the world and in order to prolong life.
So what is your opinion of when AI machines will possess human level intelligence? Will it be the same kind of intelligence, or do you think instead of more exponential intelligent characteristics, something like, hey, an AI machine can solve a particular problem which humans collectively couldn't solve it in 10 years time. It solved it just like in minutes. So that's more like exponential sort of intelligence. But where I'm getting on to is, can it also possess linear sort of intelligence, which is like doing multitasking while at the same time doing exponential research or findings, solutions, and other things? So
my opinion,
what is your opinion of that?
Based on what I'm seeing so far with our research, is that it would be the width the breadth and the depth of the intelligence would be larger than ours. It's going to be able to have copies of itself working together on different problems. So it would be able to scale out in a linear way. And as far as the depth of it being able to work on a problem, it's going to be able to concentrate and look deeper and incorporate more information sources into itself than a human would have the capacity to do, without the inefficiencies of how humans have to communicate with each other through language. So our language really fails us when we try to explain the sensation of red or even communicate ideas to each other. And it's such a, it's enabled us, our society, to get this far, and our civilization to build up this much, but it's still so rudimentary as far as the amount of information our brain really processes when we're doing social interactions. So for instance, there's, body language, and there's all these other types of sensations that are coming in when you're talking with someone else. There's inflections in the voice, and there's gesticulations with the hands that, you just wouldn't get when you're just reading text off a page. So, and that's what the language is, what we call language. I'm not a linguistic expert, but it's a limitation. What I see it is a limitation as far as how we can communicate. And that really bogs us down when we're trying to collectively solve a problem. And AGI is not going to have that, because it's going to develop its own language when it's insufficient to communicate certain ideas with each other. It's going to be as, if you had multiple AGIs working together on a problem, it's going to be as coherent as a single human's thoughts are with itself. It's not going to have these barriers of what does this intuition mean? It's going to be able to communicate it in a way that's ideal, in a way that human language cannot transmit that information. So it's going to have a higher bandwidth in that regard. Yeah, there's so much more that an AGI is going to be able to do that a human cannot. There might be some things that humans will, always be the best at. I picture it as a Venn diagram. That there's an overlap of what humans and AGIs can do, and the AGIs will probably do those things better. And AGI will also be able to do things that humans would never be able to do, even in coordination with a group of humans, right? And there may be a subset of things that humans excel at that the AGIs just never really find useful to do. So it's the amount of intelligence that it would be able to manifest is something that's, it's very attractive, and it's the root at what makes it feel like a worthwhile goal to sacrifice, to sacrifice other things to pursue this goal. It feels, to me, I would estimate it's like better than trying to find a cure for cancer. It's more meaningful. It's like creating a new species and creating a new type of life. This is something that will hopefully aid us and allow us to, kind of transcend our mortal bodies, but this is, or live longer and, aid us in other ways with our, the ills of society and the problems we face today. But this is, it's very exciting because the extent of the intelligence is unknown, but I can see it scaling both ways, in both breadth and depth.
What do you think? Are we alone in this universe? And, there are millions and millions of stars and star systems in our observable universe. And they say that, with every star system, there is a habitable planet like Earth, or in a Goldilocks zone. So it's very much a possibility that we are not alone. But let me attach this question to sort of AI, which is, of course, we might not be able to identify it or comprehend it with our limited intelligence. But maybe in the future, an AGI, which is exponentially more intelligent than us, can think beyond, our comprehension, more like a god. Do you think we will sort of decipher that first? Or do you think, in the future, technology and AGI will be able to find out the right solution of whether we are alone or not?
Yeah, I'm not sure about that. I have some opinions about that. We should probably act like we are not the only intelligent life in the universe, even if we don't have the means to observe it today. And I think that, if you looked at what is practical for a civilization to exist a long time, and I think others have echoed this, that the type of civilization that we're likely to encounter might be an artificial intelligence type of, non-biological intelligence, I should say, that would not have the problems of evolution that are, or I would say weaknesses of the body that we have, right? We're only one massive meteor from being extinct as a species, but something that can be extraplanetary and spread and prolong its existence outside of its own solar system. That's something we are statistically more likely to encounter in the future, if we were able to recognize what its communications would be and observe some sort of signals or patterns from an intelligent species or being outside of our solar system. Yeah, I don't really have, I don't spend too much time postulating on it, because it's, you could think of maybe there are big things going on. Maybe there's a war going on. There's big things to think about. But there's also something tactical that I could do right this moment. And for me, that is working on AGI and trying not to get too caught up in just pondering. Like I wouldn't want to just sit around and ponder things. I need to build things and try to work on problems and actually solve what I think is possible to solve. And finding out if we're alone in the universe is more of a, kind of a theological, hypothetical question. And, if it comes to that point, that we discover that we're not alone in the universe, obviously that upsets a lot of our, theological traditions across all of humanity, and, hopefully would bring humanity together and all the good things that we would expect ourselves to do when we see some sort of transcendental unit of belief that comes around, where we have to reassess what is actually meaningful and stop the infighting, things like that.
Yes, great point, Daniel, and great way to end our podcast on a very optimistic note as well. So yes, I had really great time again in this episode with you and learned a lot. And I'm pretty sure I will go back, and then after I finish this episode, upload it, I will be listening to it again and again to sort of, comprehend what all we had.
It was
discussed.
a lot of fun, and I've really enjoyed watching the episodes on your channel and seeing the podcast kind of pick up. And I think it's great. I look forward to you having Lex on sometime in the future, and see you on Joe Rogan, etc. Look forward to more discussion on AGI.
That's right. Yes, that's quite flattering though, because I have written to Lex, but it looks like he's really, really busy. Daniel is actually talking about Lex Fridman, both of our favorite artificial intelligence researcher. And yes, so definitely, Daniel, I mean, again, sometime soon in the future, as and when our schedules match up, I would again invite you to have a solid podcast again on AGI and
enjoy that a lot.
Topics.
Thank you so much.
Fantastic.
All right, you too.
Thank you then. You have a great day.
Bye.
Thanks. Bye. Thank you for listening to this podcast. Please support this podcast by liking, commenting, sharing it with your friends, and also subscribing to this channel. Thank you, and we'll see you next time.